Hi, everyone. I'm Renee Yager, Director of Marketing at EPC, and I'm joined today by our CEO and co-founder, Alex Lido. Hi, Alex.
Hi, Renee.
So in this segment, we're going to discuss 48-volt applications for GaN in high-density computing and data centers. So what are the major trends that you're seeing in this sector that create an opportunity for GaN?
So, advanced computing applications like those required for cloud computing, artificial intelligence, machine learning, and multi user gaming are putting much higher demands on power converters to deliver much more power in smaller form factors. So, we're seeing a fundamental shift in the server architecture that significantly increases efficiency, shrinks size, and reduces system cost.
And I believe we actually have some examples of customers that are already making this migration from the traditional bus architecture to the new architecture that you're referring to. Could we look at some of those?
I thought you'd never ask. We have a few examples here. These are examples. The first one's for 48 volt to 6 volt LLC converters for the high density server market. And this going to the lower voltage of 6 volts or 5 volts allows for much smaller and thinner secondary stage and improves the overall efficiency of the system. This first example is from Syntec, a Delta company, and uses our latest generation 100-volt devices to achieve 300 watts with an amazing power density of 1,700 watts per cubic inch. Now, MPS also offers a 300-watt solution using our latest generation devices, and these solutions are therefore dual sourced.
So what are the advantages that these customers see from moving to the 48-volt to 6-volt architecture?
So when you lower the intermediate bus voltage from 12 volts to 6 volts or 5 volts in many cases, this allows a change in technology from power MOSFETs on the secondary side to higher density BCD-MOS ICs. Additionally, the point of load converters that were 12 volts to 1 volt using power MOSFETs are also shifting now to 6 volts to 0.6 volt point of load converters that also use monolithic BCD-MOS devices. Syntec and MPS are just two of the forward-thinking companies that are releasing GaN-based solutions to support this 48 volt to 6 or 5 volt high-density server architecture.
So those are some great examples of customers that are using some leading edge designs. However, as the server power architecture makes the shift to 48 volt to 6, there are still going to be legacy systems which rely on the traditional 12 volt power. Does GaN also have a play there?
Yeah, GaN actually has a significant advantage in this power stage as well. Here's an example of a demo board we built working with Microchip. And it's a bidirectional 48 volt to 12 volt that fits into a 16th brick footprint. This solution is capable of 300 watts in this tiny 1/16th brick format and achieves a peak efficiency of over 96% up to 25 amperes.
Okay, so we've seen some great examples of the advantage GaN can provide on the server side. What about the PC side? Is there an application for GaN there as well?
Yeah, an ultra, there's this rapidly emerging example. Again, at 48 volts, although it goes all the way up to 59 volts, and that's the power for high performance computing systems. And two of these systems, ultra thin laptops and high-end gaming systems, require higher power in small form factors. So, for example, gaming computers need approximately 250 watts or even more. And even regular computers, laptops and notebooks will go up to about 100 watts so they can accommodate ultra fast charging. These systems are adopting a solution that will take 56 volts from the AC adapter and then plug that into your computer. And then inside the computer, it goes from 56 volts down to 19 volts. And to accomplish that, of course, the solution needs to be extremely thin and extremely efficient due to the thermal limitations inside a very thin computer. Here we're showing a nominal 48 volt to 19 volt multi-level converter powering an MSI gaming system in this case. And despite this very small form factor, this solution can achieve the incredible efficiency at full load of over 98%.
So I believe that this converter we also developed working with our friends at Microchip.
Yeah, in fact, we developed this multi-level converter in conjunction with Microchip and Worth, as because Worth is important because magnetics are another key consideration when using fast switching GaN devices.
Mhm.
This multi-level topology we employed allows for extremely thin inductors. In this solution, the Worth inductor is only 3.5 millimeters thick, enabling an ultra-thin, ultra-efficient solution.
So that's absolutely perfect for the latest ultra thin laptops that are coming out on the market. So thank you so much, Alex. Those examples certainly show that GaN offers the best performance in the smallest size, and it can address these very high volume markets like data center and computing.
Yeah, and we have a growing family of products for these applications, including an integrated power stage, the EPC 2152E power stage, which is a single chip which has driver plus EGAN FETs in a half bridge power stage. It will take ground base or ground reference logic in, and it produces a half bridge worth of power out.
Great. Well, thank you again so much for your time today, Alex.
Well, thank you.
And thanks everyone for watching. If you'd like some more information on EPC solutions for 48 volts, please visit our website at epc-co.com. Thank you.